Hi everyone. Today's video we are discussing about the real number. Last three videos we are discussing about the rational number, irrational number, and the number system. So in today's video we are discussing about the real number. Real numbers are nothing but the combination of whatever we see before, that is real number. So let's go with the video. Real numbers. Real numbers where to build from. First of all, real numbers we take a big circle. Inside this, we have another circle. So this is real, this is irrational, this is rational, this is integer. So there are three parts inside the real numbers. So integer, rational, and irrational. And in the last three videos I already told, the last three videos I talk about this integers, rational numbers, and irrational. So if you have any queries with that, you can ask me in the comments. And as well as I don't explain much more in this video, so you can want to know about these things, you can check it that video. I will it in the description. So first of all, we just think about the integers. Integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, and etc. What about rational numbers? Rational numbers are in the form of p by q, where p and q are integers and q is not equal to 0. So this is something is in the form is called rational number. So now irrational. So the same thing, but something is not in the fraction. Something is not written like in the fraction like this. That is called irrational. So this is the opposite of this. So we like to take. So for example, root two. Root two we cannot able to write in this form. So it is 1.414 etc. And it is non-repeating and not terminal. Okay, so now see what is real. So real numbers are built from these things. So real numbers real numbers contain these three things: irrational, rational, and integer. And this is the real number. Now see the magic of continuum in real numbers. In the world of integers, between 1 and 2, that is none of the number inside and in between them. So, but in real number, the world of real number, we denote as this as real number. So between 1 and 2, there are infinite numbers are there, because we just take in between this is 1.5. So 1.5. So suppose one yeah, suppose 1.5. Now see, between 1 and 1.5 we have 1.25, right? So forever we can zoom it zoom it like it is in a number line. So here 1 and 2, so we can zoom it. You see there is 1.1, 1.2, 1.3, 1.4, 1.5, like this. So again you see, when you want to zoom, it will be like 1.1, 1.2. So in between this two, we have 1.11, 1.12, 1.13, 1.14, 1.15, like this. So again you zoom it, you can go with that. So it doesn't stop in anywhere. So it contains, in between 1 and 2, it has infinite numbers in between this. So this is the magic of continuum. Now see the real life example. We just take a day. In a day, you see in the morning the temperature will be maybe 24.5 degrees Celsius. So after a few minutes or a few hours, it differs from the morning you see. Maybe you see in the morning 7 o'clock it's 24.5 degrees Celsius. Maybe in 10 o'clock it is increased by 28. It's possible, right? So after at 12 or 1 o'clock, 1 p.m. or 2 p.m., it was too hot in Chennai. So in that time it's almost 32 or 33 degrees Celsius. So later, after 3 or 4 o'clock, again the degree will be reduced. So from that, what we see, it doesn't jump from 124 to 30 or 24 to 25. So it moves a real point like in that infinity we already talked about. Okay. So from 24.5, it again changed 24.6, 24.666, 24.6666667, like this. Like this flow is maintained in that. So it doesn't jump from one point to another. It's a flow, but we couldn't see easily. So this is one example. And another example is in a clock. In a clock, the time just doesn't jump into 1 to 1 1. It's also a flow from 1 1, like 1 o'clock, 1 maybe 1 o'clock, 1 minute a.m. a.m. So here see, it doesn't jump from like 1, it doesn't jump directly to this. It takes a flow. It moves from a 60 seconds. You just see the 60 seconds to below that 60, there is a milliseconds. So from we can zoom to go inside it. We see a lot of things in that. So this is one example. Another example, we are used this real numbers in engineering to build a bridge or a 3D graphics or a lot of things we have to use this real number. So this is the real numbers most interesting thing. And in the next time you see the root 2 or pi, you don't think that is just a number. You see there is an architecture of this real number. So thank you.